Hey everybody, welcome to part one or lesson one on angle proofs. There will be two parts to this, which I will break up over the next couple of days for our lessons so that we can take it little by little. We're going to start out with just a quick review of information that we have already learned, which is those special angle pairs from earlier this week or earlier in this unit, linear pairs, supplementary, complementary angles, vertical angles, things like that. And so here's the first thing that I want us to start out with. We've got angle one and angle two are a linear pair. For the record, if you are in my geometry class currently, hush baby, you're gonna hear my baby, my 1-year-old talking potentially, but also you may have a copy of these notes if you are in my existing geometry class. If not, then you can just pause this video and write these down as we go. And so here we go. Again, angle one and angle two are a linear pair. The measure of angle two is 6 more than 2 times the measure of angle one. Find the measure of both angles. And so the first thing I'm always going to encourage you to do in this class is, when in doubt, draw yourself a picture. And so that's the first thing I'm going to do, is I'm going to draw myself a picture of a linear pair. And so what I remember about linear pairs is that they are adjacent angles, meaning they share a vertex and a side. And those two angles, those two adjacent angles, add up to be 180 degrees. Okay, so the next thing that I know is angle one and angle two. And the only reason I know that's because that's what the directions gave me. Nothing crazy. I'm not making anything up. That's just what was given to me. Angle one and angle two are a linear pair. The next thing that I know is the measure of angle two. So the measure of angle two is, that usually indicates an equal sign. So the measure of angle two is 6 more, or 6 plus 2 times the measure of angle one. So 2 times the measure of angle one. This is straight from Algebra 1 content, being able to read in words and then rewrite it as an algebraic expression. Okay, so that was the first thing, was we drew the picture, we took care of sentence one, we took care of sentence two by writing this algebraic statement, and then I want the measure of both angles. Well, what do I know about the measure of angle one and the measure of angle two? They are a linear pair, which means they add together to be 180 degrees. Okay, so that's what we know about a linear pair. But think about it, if we were setting up a proof and this was given to us, we would then say the definition of a linear pair says the measure of angle one plus angle two equals 180. Then our third step would be the measure of angle two equals this. So I can substitute that in to that statement. Okay, and so instead of 1 plus 2, or the measure of angle 1 plus the measure of angle 2, I could say the measure of angle 1 plus substituting in 6 plus 2 times the measure of angle 1. And all of that equals 180 degrees. Okay, this is not a proof. Okay, nowhere in the description does it say write a 2-column proof, or does it say given this, prove this. Okay, so you do not have to write a proof. I'm just always trying to keep you in that mindset of, here's what I'm doing, then justify it. Here's what I'm doing, why am I doing it? And so that's why I said, if you're doing a proof, you're going to substitute in. Now, I know that this may look a little funky to you. It may look a little weird. If you want to swap that out and just call it a variable, that's fine. You just have to remember that that represents the measure of angle one. Okay. Otherwise, I would suggest sticking to using the measure of angle one notation. Okay. So our next line, I've got the measure of angle one. There's one of those. And then I've got another 2 sets of measure of angle one. So one measure here, two measures here. What is one measure plus two measures? That means we have three measures of angle 1. Again, if that freaks you out, then call it X. So it would be X plus 6 plus 2X. Then down here, when you combine your like terms, it would be 3X plus 6 equals 180. If I'm going to solve that equation, I'm going to subtract 6 on both sides, which would leave me 174. Then I'm going to divide by 3 on both sides, which would give me what? I'm going to have to say 80, not 80, 50. 3 goes into 17 5 times, carry the 2, 58. Okay. So the measure of angle 1 is 58 degrees. Don't forget your degree sign. It's going to take me a few extra seconds to do that because I'm having to type it, but all you have to do is write it. So if the measure of angle 1 is 58 degrees, then what is the measure of angle 2? Because that is what my question asked me, is tell me what the measure of angle 2 is. Well, if angle 1 and angle 2 are a linear pair, that means they add to 180 degrees. That also means I can say 180 degrees minus angle 1, and that will give me the measure of angle 2, which should be what? 122 degrees. Again, don't forget your degree symbol. You can go back and check your answers. Is 58 degrees plus 120 degrees equal 180? That way they are an actual linear pair. And the answer is yes, they do. Go back to your directions. We are asked to find the measure of both angles, and we did that. Okay. All right. So we're going to move on. Today, we're going to be using angle addition postulate a good bit. We're going to be using some of those angle pair relationships potentially, but you're really going to see a lot of similarities between how we started out with solving equations within proofs. So we're going to start out in a very basic format, and we'll build and escalate as we go. So here's our first proof. Feel free to pause this video if you need to in order to draw the diagram if you don't have these printed out or if you don't have access to these notes. But always, always, always draw the diagram, label it based on what is given to you, and then we will go from there. Okay, so I'm going to pause the video and I'm going to do some labelings. So you'll notice that I've got everything labeled based on what was given to me. I would like to point out that I don't have to write that out for you. And the reason why that doesn't have to be there is because it was already drawn in the diagram. So if that was labeled in the diagram and you still have a proof, that's still technically given to you. And so you would still be able to say angle 2 is a right angle given because it's written or it's labeled in your diagram. So I just wanted to point that out. You may see something like that where it's not written in the given, but it's already labeled in the diagram. That is still considered given to you. Okay, so here we go. I'm just going to copy that and I'm going to move it down here as my first step. Here we go. And the reason why is because it is given to me. Okay. And so I want to find out what, or I want to prove more like it. Remember, this is a proof. So we already know the answer. We have to explain why. Why is the measure of angle 3 18 degrees? Prove it, explain it, justify how that answer gets there. So how would I go about starting this proof? I want to prove the measure of angle 3 is 18 degrees. When I come over here and look, I see that I have a piece of an angle. I have a piece of an angle. I want the last piece, and I know the total. So when I start thinking I've got a piece and a piece, I'm looking for the last piece, and I have the total, that starts, if the more times I say that, that more that sounds like I've got this plus this. I'm looking for that next part equals the total. That sounds just like an equation. And when we're dealing with angle measures, that means angle addition. So I'm going to say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals the measure of angle ABC. How do I know that? Where did that come from? Well, I'm looking at the diagram. Angle 1 plus angle 2 plus angle 3 gives me the total of that largest angle ABC. Okay. And what's my reasoning for that? Angle addition postulate. So just like segments, add the pieces of the segments to get the total segment measure or segment length. Same thing with angles. I'm going to add all the small angle measures to get the one total or the one big angle measure. Okay. Now from there, the only other things that I have are what's given to me. So just like we do in almost every other proof, I'm going to take what's given to me and I'm going to substitute it in. So instead of angle 1 or the measure of angle 1, I'm going to substitute in 23. Instead of measure of angle ABC, I'm going to plug in 131. Instead of measure of angle 2, I'm going to plug in 90 degrees. And look at when I do that, the only thing left is the measure of angle 3, and that is what we are trying to prove. Okay. So my very next step, measure of angle 1 is going to become 23 degrees. That's going to become 90 degrees. I still don't know the measure of angle 3, or I still haven't shown what it is. So I'm going to leave it. And the measure of angle ABC is 131 degrees. How am I able to do that? Substitution, if I can spell it. This is a property of equality. Why is it a property of equality? Because I'm dealing with the measures of angles and an equal sign, not a congruency mark. Now, if I gave you 23 plus 90 plus X equals 131, what would our very next step be? Well, our very next step would be to combine like terms, most likely, right? Combining like terms is a mathematical property. It is a mathematical thing that we are allowed to do. So that's the first thing I'm going to do. In order to solve for the measure of angle 3, to solve this equation, I'm going to have to combine some like terms. So I'm going to add 23 and 90 together to get 113 degrees, plus the measure of angle 3 equals 131. Now, what's our justification? Well, I just said combining like terms is a mathematical licensure. It gives us, like, it's a property, or it's a, I don't know the exact word to use. It's slipping off the top out of my head right now, but it's a mathematical allowance, if you will. It is something that we are allowed to do. In fact, we are required to do in order to solve equations or simplify expressions. Okay? And so the justification of combined like terms is perfect. That will work absolutely. If you are enrolled in one of my classes, your Unit 1 test, you would remember a proof where one of the justifications said combine like terms. I gave you that because we hadn't necessarily seen that yet, but now you have. So now you know that you can use that as a justification in your proof. Now, to finish out, I want to know, or I want to prove that the measure of angle 3 equals 18. So I only need the measure of angle 3 on that left-hand side. So what do? I subtract 113 from both sides of the equation, and that wonderfully gives me 18 degrees. Why am I able to do that? Well, I subtracted on both sides of the equation. So that is the subtraction property of equality. Have we proven what we were asked to do? There it is. Is that my very last step of this proof? Yes, it is. That means I am done. In your higher level math courses, or maybe even in college, you may hear the term QED, which means done. And so now we will move on to the next one. So this next proof, It says given angle 6 and angle 7 form a linear pair, and the measure of angle 6 is that, and the measure of angle 7 is that, prove that your variable x equals 17. Now, I have provided a diagram here. It's very basic and it needs to be labeled, but I have provided one. But maybe I don't give you one, or maybe your instructor hasn't given you one. That's okay. You don't have to be given one in order for you to still utilize one. Because I am given angle 6 and 7 form a linear pair, I immediately know, well, I better draw a linear pair, which is a pair of adjacent angles that form a straight line. The formal definition is a pair of angles that are adjacent, meaning they share a vertex and a side. Their non-common side forms opposite rays. Well, another way to describe a line or to define a line is a pair of opposite rays. So angle 6 and angle 7 form a linear pair. It's a pair of adjacent angles that form a line. We know that that means that they add up to 180 degrees. And so we're going to keep that in the back of our mind. How do we know that? That's the definition of a linear pair, or your instructor may have introduced to you the linear pair postulate. It really just depends on, I'm a geometry teacher and I love it. It really just depends on how strict and formal your instruction is in geometry. Some teachers will just take linear pair, whether you put definition or postulate. Some instructors may be very particular. They may say definition of a linear pair is when they are a pair of adjacent angles. So you have to state that they are a linear pair by the definition, and then that they add to 180 degrees by the linear pair postulate. I am not as strict as some geometry teachers, because I have found that that usually ends up just costing my students a lot of points on assessments when they understand the terms and the content. Another thing that I will say is, based on the textbook that you have, it may be called something slightly different. For my students specifically that I have, Miss Windsor's students, I will accept definition of linear pair or linear pair postulate. And so we'll go from there. All right. Now, enough about that. That was just to help anyone that may be viewing this video outside of my class. There's not very many materials out there on geometry, especially geometric proofs. So there you go. There was your freebie on explaining some things. Next, I want to label my diagram. I want to label, let's see. I want to label angle 6 as 3x. I probably should type this, but here we are. 3x plus 32. And that is an angle measure. There's not degrees written up there. Okay, but there should be. Okay, so that's 3x plus 32 degrees. And then angle 7, I'm gonna get smart. I'm gonna do that. The measure of angle 7 is 5x plus 12 degrees. And so that is what we're gonna start with. I'm just gonna copy and paste that down again. Let's see if I can make this work. Yeah. Now, obviously you would want to write it to where you can read it. I'm just trying to save myself a little bit of time and allow you a few minutes or a few seconds to write it down yourselves. We don't need the proof statement there. We just need what's given to us. Okay. And then why am I able to say that? Well, first step in your proof is always your given. If you're in my class, I've explained that sometimes you don't have to put all of the given in that first step. Since this is an open-ended proof, I always advise that you do that. But sometimes you may be given portions of a proof that you have to fill in. And in that situation, they may give you some of the given in step 1, but then down here in step 5 may be more of the given. Basically, you got to keep your head up at all times and be alert. So that you can pay attention and know where things are coming in, so that then you can substitute them if you need to. Okay, so my next step, angle 6 and angle 7 form a linear pair that is given to me. I immediately know that the measure of angle 6 plus the measure of angle 7 adds up to 180 degrees. And I know that because if you're super formal, that would be the linear pair postulate. For my students, I accept either one. So you can put the definition of a linear pair or linear pair postulate. Okay. Now, that's pretty much all I know based on what is given to me. I always advise my students that I have right now. I mentioned this in class, but if you ever get stuck, I always tell them to draw a dairy cow with udders and write each of the given on the udders. And I know that sounds ridiculous, but it's a great visual because I want you to milk the given for all it is worth. Okay. If you don't do that, then you're never going to get your proof correct because what you were given is what you are supposed to use. Tell them, baby, tell them. I hear you. Good job. Okay. What you are given is what are the tools that you need in order to fully explain a proof, to fully explain the information that they have asked you to explain. So always milk it for what you can get. So I'm going to just do a quick highlight here. I'm a big fan of highlighting if you can't tell. So I utilize that part of my given in this second step. The part that I haven't used is right here. The measure of angle 6 equals that, and the measure of angle 7 equals this. Well, if I look in that very next step, I've got a measure of angle 6. Can I substitute? No, ma'am. Okay. I've got a measure of angle 7 here as well. Can I substitute? That seems like the logical next step to me, so that's what I'm going to go do. Uh-oh, here we go. There we go. So instead of the measure of angle 6, I'm going to say 3x plus 32 degrees for the measure of angle 6. I'm going to substitute plus whatever the measure of angle 7 is, which is 5x plus 12 degrees equals 180. Okay. Shrink this down just a little bit. Okay. Why am I able to do that? Well, I've been saying substitution over and over and over again. So that's the property I'm going to use to justify my answer. It's an equation, so it is a property of equality that allows me to do substitution. Okay. Now, if I were to give you this statement in Algebra 1, you would combine your like terms, probably do some subtraction, or division, or sorry, some subtraction or addition, and then some multiplication or division, depending on what's given to you. So let's start out with what we would always do given an equation. We would combine like terms. So I wrote these things in parentheses. I advise my students anytime I substitute to write things in parentheses. That way, if there's a coefficient, I don't miss out on my distributive property, anything like that. For this situation, for this case, I don't have a coefficient here, so there would be no distributive property missing out. There would be no symbols that I am missing either. It would just be, all right, now I can look at all that and I can combine my like terms. 3x plus 5x is 8x. 32 plus 12 is going to be 50. No, sorry. It will be 44. My apologies. And that adds up to 180 degrees. What's my justification? Combine like terms. Next thing I'm going to do is I'm going to subtract 44 on both sides. 180 minus 44 is going to be 136. What did I do? I subtracted on both sides. So that is the subtraction property of equality. Last thing I want to do, I'm trying to prove that x equals 17. Right now I've got 8x. I only need x. That forces me to get rid of the 8. And the only mathematical way for me to do that is either divide by 8 on both sides or multiply by its reciprocal of 1/8 on both sides. I would typically say that you're going to see the division aspect more so than a multiplication. But again, it just depends on how your instructor has explained that to you or your past content, how that has been explained to you. If you showed that work, so like if you wrote down here lightly times 1/8 on both sides, then you could say it's by the multiplication property of equality. But most people are going to say divide by 8 on both sides. And how do I do that? The division property of equality. So we're close to wrapping up this part 1 of angle proofs. Before we wrap up, I've got one more proof, but it's a very short one. Again, I apologize for my child in the background. She loves to read, so she's reading out loud in her own language. Anyways, we've got one more proof, and it's actually going to be explaining a theorem. Before we get there, I just want to remind or introduce a couple of properties. You should all have seen reflexive and symmetric and transitive properties. You should know that there is a version of these that is property of congruence, meaning congruent angles or congruent segments. And then there is a property of equality, or POE, as you have seen me abbreviating. That is when we would have the measure of angle 1 equals the measure of angle 1. Or for the symmetric property, the measure of angle 2 equals the measure of, the measure of angle 1 equals the measure of angle 2. Then I can swap the order. The measure of angle 2 equals the measure of angle 1. You should have seen the properties of equality at the beginning of your unit or the beginning of your course in geometry, but if not, here you go. This slide is specifically just to show you that you can use these in congruency statements as well. So I don't have to convert that to the measures of angles before I say that they're equal. I can say that they are congruent using the reflexive property of congruence, or I can swap the order of these named angles using the symmetric property of congruence, or POC, and still leave them as angle names. Now, if I do anything else to them, if I want to substitute, if I want to add something to both sides, I've got to convert these to the measures of angles using the definition of congruency. Okay, but if all you're doing is trying to swap the order or condense using transitive property, you can use that or do that using congruent statements. Okay. The next thing, there's two new theorems that I want you to add to your tool bucket of theorems and postulates for geometry. The first one is the congruent supplements theorem. Now, before you start reading, I just want you to actually break down that title. So you've got congruent, and we should know by now that congruent means that if the names are congruent, then the measures themselves are equal. So whatever I'm dealing with, I can say that their names are congruent. And then the measures of those are equal. Okay, so let me keep, no ma'am. So let me keep going. Now I have the congruent supplements theorem. So supplements makes me think of supplementary. Supplementary angles are two or more angles that add up to 180 degrees. Okay, so now I've got congruent supplements theorem. So if I try to put that together just to figure out what this might mean without even reading it, it makes me think I'm going to be dealing with supplementary angles that add up to 180 degrees, and somehow some of them may be congruent to each other. Okay, so now I'm going to read the definition or the explanation of this theorem. It is angles that are supplements or supplementary to the same angle, or congruent angles are congruent. Now, a lot of you probably heard me or were following along with me and you thought, what in the world did she just say? Okay, I like to think of this. I like to think of this as kind of a branch off of the transitive property, if you will. So the transitive property says if angle 1 equals angle 2 and 2 is equal to 3, then that means 1 and 3 also must be equal. Or if it's the transitive property of congruence, if angle 1's congruent to 2 and 2's congruent to 3, I can smash all that together. I can condense it down and say 1 and 3 are congruent. Okay, so the congruent supplements theorem is very similar to that. I need you to go read some books, okay? Thank you. Mama loves you. So here is the slight difference between the transitive property, and then this congruent supplements property theorem. Okay. The measure of angle 1 plus 2 equals 180. Okay. These two are supplementary. They add up to 180 degrees. Okay. So let me do this plus this is 180 degrees. They're supplementary. Okay. Now, what if I also told you the measure of angle 2 and the measure of angle 3 are supplementary angles? They add up to 180 degrees. What if I told you that? Okay. Well, angle 2 has to be the same measure in both of those statements. Here they are written out for you. Angle 2 has to be the same measure in both of those statements because it's angle 2. It's the same diagram we're referring to, same problem. Okay. 180 degrees is 180 degrees. So what's the only thing left? We got angle 3 and we got angle 1. Do you see how angle 1 and angle 3 have to be equal? The measures have to be equal, which means the angles themselves have to be congruent. Okay. Right. So that's the congruent supplements theorem. Okay. Now, what's the difference between this and the regular supplement theorem? The regular supplement theorem just says this angle plus this angle adds up to 180 degrees. That's this right here. That's just the regular supplement theorem there, or the definition of supplementary angles, again, depending on how strict your instructor is. The congruent supplements theorem says, oh, I can take two of these statements. If they have anything in common, like angle 2 and angle 2 are the same, then I can jump right to 1 and 3 are congruent using the congruent supplements theorem. Okay. Guess what? There's a congruent complements theorem as well. And it works the same way, except it's complements, meaning they add up to 90 degrees. So we'll walk through that same structure. All right. Here's the measure of angle 4 plus the measure of angle 5 is 90 degrees because they are complementary angles. But the measure of angle 5 plus the measure of angle 6 also adds up to 90 degrees. The congruent complements theorem says, all right, the measure of angle 5 is the same. Look at it in the diagram. It's the same one angle, measure of angle 5. 90 degrees and 90 degrees are obviously equal. They're the same. So what's left? Angle 4 and angle 6. They must be the same measure, which means the angles themselves must be congruent. So what does that look like in a proof? Here we go. I've got the measure of angle 1 and the measure, or sorry, angle 1 and angle 2 are supplementary. And then angle 2 and angle 3 are supplementary. Now, just a helpful, like just side note, does it say that these are a linear pair? It does not say that they are linear pairs. So when we draw our diagram, if you draw it as a linear pair, you need to keep in mind that that's fine and dandy. Visually, that's an easy way to know they add up to 180 degrees, but that is not what we are given. We are given angle 1 and angle 2 are supplementary. So we're looking at the most accurate diagram would be something like this. Angle 1 and angle 2 are supplementary. Then we know that angle 2, which we already have drawn, and angle 3 are supplementary. So I need an angle 3. And keep in mind, diagrams are not drawn to scale. That is very clear based on my picture. Okay. And we have angle 3, right? So here we are. Here's our given. Here's our given. And we're trying to prove that the measure of angle 1 is congruent to the measure of angle 3. And we know that because it is given to us. All right. So angle 1 and angle 2 are supplementary. Well, what does that mean for the given? That should tell us the measure of angle 1 plus the measure of angle 2 is 180 degrees. And the only reason I know that is because I was told they're supplementary. And again, depending on the strictness of your instructor, they may want the supplement theorem as an explanation. For my specific students, I'll take the definition of supplementary angles or the supplement theorem or the supplementary angles theorem. I'll take either one. Okay, so that's that first part of the given. I also have angle 2 and angle 3 are supplementary. So the measure of angle 2 plus the measure of angle 3 are supplementary. They add up to 180 degrees. How do I know that? The supplementary angle theorem or supplement theorem, or if you're one of my students, you can say definition of supplementary angles. Not a linear pair. You're told nothing about a linear pair, so you can't use that. Maybe later, okay, but not in this proof. You're not allowed to use that because you weren't given that information. So now let's take a look at what I have. I see the measure of angle 2 here. Stop, Everly. The measure of angle 2 here and here. I also see the measure are 180 degrees and 180 degrees. I've got 2 out of the 3 things in these 2 statements that are the same. So very similarly to the transitive property, I can say that the measure of angle 1 equals the measure of angle 2, or the measure of angle 3. Now I could say that as, I could say that by subtracting the measure of angle 2 on both sides and then substitution. I could get there in a different way. Or if I wanted to go straight to my proof, which says angle 1 is congruent to angle 3. Gotta do my squiggle. If I wanted to go straight to that step, I would be allowed to, but the only way I'd be allowed to do that is if I said it was by the congruent supplements theorem. Okay. Now, if you're never going to remember that theorem, then that's fine. You may need it someday, but if you're just refusing to remember that, you could always, okay, so you could always get to it a different way. So I'm going to highlight right here because we won't be using that one right now. But I could technically get there in multiple steps. So if I just picked up right there at step 2 instead, I could say the measure of angle 1 equals 180 minus the measure of angle 2, and the measure of angle 3 equals 180 minus measure of angle 2. And I'm able to do that by the subtraction property of equality. Then my next step could be the measure of angle 1 equals the measure of angle 3. Why am I able to do that? Well, I'm able to do that because these 2 things are equal, which means I can sub this out. Sorry, I can sub this out and put in the measure of angle 3 in its place. So I can do substitution property, or some of you may even say, hey, that's transitive property because I'm taking 2 separate equations and condensing them down into one equation. That would be fine. Most likely you're going to see more substitution for that. And then to get to our proof statement, angle 1's congruent to angle 3, I've got to convert it back to the name of that angle. And don't forget your congruency sign. And the way that I convert it back to a congruency statement is the definition of congruency. If your teacher's very particular, they may require you to say the definition of congruent angles since you're dealing with congruent angles. For my students, I usually just say the definition of congruency is just fine because it means the same thing. So you see how this proof can either be 1, 2, 3, 4, 5, 6 steps, or it can be, 1, 2, 3, 4, 5, 6, 7 steps, or it can be 3 steps or 4 steps, however you want to count it. So if you know this theorem, the congruent supplement theorem or the congruent complements theorem, it'll just save you some time. Not necessarily a requirement for most proofs, but it just takes you much longer to prove something. So that is the end of part 1. I hope you enjoyed it. Students of mine, of Miss Windsor, if you have any questions, feel free to reach out. My child's changing the slide or changing whatever we're looking at. Anyways, stop, Everly. That is all I have for you today. And so that is the end of part 1. Stay tuned for part 2.